In this video, I'm going to solve the problem 54 from chapter 19. A quantity of ideal gas at 10 degrees Celsius and 100 kilopascal occupies a volume of 3 meter cube. First question, how many moles of the gas are present? And the second question is, if the pressure is now raised to 300 kilopascal and the temperature is raised to 30 degrees Celsius, how much volume does the gas occupy? Assume no leaks. So here we have to again answer for two questions. So for that, first of all, we have to write the given. Once you write the given, it will be very easy for getting the idea for answering these questions. So what is given in the question? In the first part, they gave the initial temperature. What is the value of the initial temperature? So Ti value they mentioned here as 10 degrees Celsius. If you convert this value in terms of Kelvin, we have to add 273. By that, the value of the initial temperature here as 283 Kelvin. And also they mentioned the initial pressure. What is the initial pressure? The initial pressure they mentioned here as 100 kilopascal. So what is the kilo stands for? The kilo stands for 10 to the power of 3. So 100 multiplied 10 power 3 pascal. And also they mentioned the initial volume. What is the initial volume here? The initial volume they mentioned here as Vi, which takes the value of 3 meter cube. So here the first part we are going to find the answer for the number of moles, but anyhow we will write the remaining information. So in the second part they say we have to again increase the pressure to 300 pascal. So what is the final pressure? Here the final pressure is 300 kilopascal, which takes the value of 300 multiplied 10 power 3 pascal. And also they mentioned the temperature. What is the final temperature? The final temperature is 30 degrees Celsius. If you add 273, we will get the answer of the final temperature as 303 Kelvin. So these are all the information given in the question. By using this, we are going to answer for two questions. In the first part, we are going to find the number of moles. So for this, what I'm going to do, I'm going to use the ideal gas equation. So what is the ideal gas equation? Ideal gas equation, which is equal to PV is equal to nRT, right? So let's we take this ideal gas equation for the initial case. What is the initial condition? Because I'm going to use all the pressure value, volume value, and the temperature value initial conditions. What is the initial condition pressure? In the initial condition, the pressure is 100 kilopascal, initial temperature is 283 Kelvin, and the initial volume is 3 meter cube. So I'm going to use these conditions in this equation. So for that, I have to reframe this equation in terms of initial case. Therefore, Pi Vi, which is equal to nRTI. By using this, I'm going to find the number of moles n. So I have to rearrange this equation. Therefore, n is equal to Pi Bi over R multiplied by Ti. I'm going to substitute the value. The initial pressure here is 100 kilopascal, 100 multiplied by 10 power 3, and initial volume is 3 meter cube, which is already given in the question. Over the ideal gas equation is ideal gas constant. The gas constant value is 8.314, and the initial temperature is 283 because 0 degrees Celsius they mentioned. So we converted the 0 degree to Kelvin, which is 283 Kelvin. Let's see what is the answer for the number of moles. So n is equal to, I got the answer here as 127.5 moles. Better we can just round it the value. 128 mole we got as an answer. Clear? This is the answer for the first part. Now in the second part, what we are going to calculate, what they mentioned in the second part, if the pressure is now raised to 300 kilopascal and the temperature is raised to 30 degrees Celsius, how much volume does the gas occupy? That means we are going to find the value of the final volume. So for calculating the final volume, I am going to use the same ideal gas equation for the final state. So let's do answer for the final state. So P final, V final, which is equal to N or T final. We can use this. By that I have to rearrange this equation because the number of moles will be same for initial and the final, and the gas constant is a constant value, and we have the final pressure, we have the final temperature. By using all these, we can easily find the value of the final volume. So I have to rearrange this equation. Therefore, V final, which is equal to N or T final over P final. I'm going to substitute the value here. For N, I have to use the answer from the first part, which is 128. So here we got the number of moles as 128. So I'm going to use this value 128 multiply with the gas constant, which takes the value of 8.314 multiply with the final temperature. Let's see what is the answer for the final temperature, which is 303 Kelvin, 30 degrees Celsius. We have to convert that Celsius to Kelvin. So the answer for the temperature is 303 Kelvin. So 303 Kelvin over the final pressure is 300 kilopascal. So I have to use that 300 kilopascal. So 300 multiply 10 power 3. I got the answer for the final pressure here as 1.07 meter cube. So this is the answer for the second question. Clear? That's it. Thank you.